Hello everyone. So today I'll be discussing the application of using unmanned aerial vehicles UAV drones for high resolution reconstruction of topography using the structure from motion approach on coastal environments. This is one of the famous paper in the field of remote sensing, which involves some GIS aspects as well. Uh, the reason that I review this paper is because some part of what I'm gonna do in my project involves the use of UAV as well. So, uh, without discussing further, I'd like to go to the next slide. So, to begin with, why is high resolution topography important in coastal areas? It's because coastal regions experience rapid changes due to erosion, flooding, and sediment movement. So, accurate digital surface model, mm, or digital elevation model are essential for understanding these changes and protecting natural barriers like dunes, which prevent inland flooding, which we can see in the figure. The study area and traditional method for capturing topography like terrestrial laser scanner, GNSS survey provide high accuracy but comes with limitation. They are costly, time consuming, difficult to deploy over large areas. So in this study, researchers tested a UAV-based approach using SFM structure from motion to see if it could provide a reliable, cost-effective alternative. And the study area was in Italy. Mm, And about the methodology in this paper, the researchers used three main methods to collect data. One is GNSS survey. Uh, NRTK means near real-time kinematic survey. They established 18 ground control points with 126 validation points and 19 vertical targets. Another one is UAV survey, which they use the exact copter equipped with Canon EOS camera and flew at low altitude, capturing over 550 images mm, of the dune system. And the terrestrial laser scanning uh, was also used to validate the accuracy of UAV survey. And the images from UAV were processed using structure from motion algorithm in Agisoft PhotoScan. It uses the image matching algorithm like structure invariant feature transform. Uh, you will generate type point, and on the basis of type point, generate point cloud, which will lead to us to generate the DSM or DEMs or orthomosics product with the help of interpolation. Uh, Now looking at the results, the point cloud generated by UAV USFM produced over 831,000 features across the 27,500 square meter area, and the average vertical accuracy was within 10 centimeters when compared with GNSS survey data, while comparison with TLS data showed that the UAV DSM was accurate to within 5 centimeters on average with a root mean square error of 22 centimeter. Uh, However, some discrepancies appeared in areas with sharp topographic changes, and the study found that the issues were likely due to the limitation in TLS data capture rather than the UAV SFM model. We can see in the images the distribution of CCPs, uh, point cloud differences between UAV and terrestrial laser scanner, and also the elevation differences uh, in the figure. Going further to next slide. So here we can see the difference between UAV and TLS. Like from the chart, there's very less differences. So that's why people nowadays are considering the use of UAVs. Of course, there are other technologies to explore, but UAVs is kind of like standard nowadays. Uh, and going to next slide. So moving on to the conclusion part. Uh, some of the challenges in this research were the environmental factors like the wind speed uh, led like UV flight to minor deviations in flight paths, which impacted data collection, and some surface matching problem like to create a DSM in sparse areas of point cloud. Interpolation could introduce smoothing errors. Therefore, the paper recommended it's essential to assign reliable uncertainty values in while generating DSM. And the study showed that ESFM is cost-effective and highly automated method for creating accurate digital elevation models compared to expensive textile scanner methods. And future research should focus on different other technologies like Apple LiDAR, which is even cost-effective, which is kind of what I'm doing. So overall, this research uh, highlighted the potential of UAV-SFM for rapid and high-quality topographic modeling. And finally, thank you for listening. And any feedback or question, this is the reference of the paper that I reviewed. In case if anyone like to go through.